What?
and you multiply whatever is in front of it by itself, however many times it says.
Sure. Do you remember the names of these? You know what this number's called?
No.
Honesty. This is called the base.
Okay.
And the little number up here is called the exponent. And your description of what it is absolutely right. It is take the base and multiply it by itself however many times the exponent tells you to. So this is 2 times 2 times 2, 3 times because the exponent's 3. So 2 times 2 times 2. The temptation here is to say the answer is 6. Don't do it. Take your time.
Oh. Eight.
8. Very good. Piece of cake. Okay. So then if it tells you to multiply it by itself that many times, what do you do if the exponent is a 1?
It's just multiplied by 1, isn't it?
Yeah, it's multiplied by itself 1 time. So 3 times 3, but you only do it 1 time. So it's just 3. Do you know what to do if the base is negative?
Well, it depends if it's in parentheses or it's not.
Good. These two problems have different answers. The second one, the negative sign is in the parentheses. So you do negative times negative. The negative is also squared, right? Negative times negative is positive, so the answer is positive 16. On the first one, the negative is not a parentheses, which means the negative's not squared, only the 4 is squared. So you do 4 times 4, which is 16, and then you just stick a negative on front. So the parentheses make a really big difference when your base is negatives. Keep that in mind. Okay, how do you feel about fractions?
They're not my favorite thing.
So this means to do 1/2 times 1/2 times 1/2 times 1/2. But you don't have to do it that way. You could do 1 to the 4th over 2 to the 4th. 1 to the 4th is really easy. 1 times 1 times 1 times 1 is just 1. The bottom's a little worse. This is 2 times 2 times 2 times 2. You may recall from the previous problem that 2 to the 3rd power was 8. That part right there is 8. So we're doing 8 times 2, which is 16.
16.
Decimals, not too tough. This is 0.5 times 0.5 times 0.5. That's not a difficult thing to do on a calculator, but you could also do 5 to the 3rd power, which is 125. And just remember that if you do 0.5 times 0.5 times 0.5, that our problem has 1, 2, 3 numbers after the decimal. So our answer should have 1, 2, 3 numbers after the decimal, and the answer would be 0.125, which is all right. Okay. Yes, no, maybe?
Or beans.
Cool beans.
Yes.
I'm going to take that as a wahoo. Okay, so what about this one?
You have to put the exponent and the 2 together first, right?
The exponent and the 2?
Oh, no, I guess not. Just, I guess you would do the exponent and then the 5 first, and then multiply the answer by 2.
Right. If you remember, please excuse my dear Aunt Sally, everybody's favorite. The exponents happen before multiplication. So I do 5 to the 3rd power first, and then do the multiplication times 2. So we just did 5 to the 3rd power in the last problem. 5 to the 3rd power was 125. So this is 2 multiplied by 125, which is 250, which is quite a bit different from the answer you would get if you multiplied first. You'd get 1,000 if you multiply 2 times 5 and then took it to the 3rd powers. Makes quite a big difference when you do it that way.
Oh no.
Oh no. It'll be okay.
Ooh.
Exponents come before division, right? So let's take care of the exponents first. What's -3 squared?
Nine.
I guess it would just be -9, wouldn't it?
Well, -3 squared is -3 times -3.
Hmm.
And a negative times a negative is a positive. So the answer is +9. Then we do division. 9 divided by 9?
1.
1. Cool beans, as the kids say.
Cool beans.
So let's talk about how to multiply stuff with exponents together using what is called the product rule. So the product rule is a way to take a problem like this and put it together. So I'm going to show you the really long, stupid way to do this, and then we'll see if you can figure out the shortcut. So here's the long, stupid way to do it. 4 squared is the same thing as 4 times 4, right? 4 to the 5th power is 4 times 4 times 4 times 4 times 4. And I'm multiplying these two things together. So what I end up with is 4 times 4 times 4 times 4 times 4 times 4 times 4, which is the same thing as
4 to the 7th power.
4 to the 7th power, exactly right. So is there an easier way for me to do this besides writing out all those 4s when I do the problem? Because it wasn't so bad on this problem. What are you going to do whenever I give you like 4 to the 23rd power times 4 to the 2,947th power? I don't know about you, but I do not want to write out 4 times 4 times 4, 2,947 times. I don't even really want to write it down 23 times. Writing it down 5 was kind of taxing my skills. So I would really like a shortcut. Was there a way that I could go straight from the problem, which was that, to the answer, which was that?
Just add them?
Yeah, I just add the exponents. The way you'll see this written in a math textbook, if you decide to crack one open, and why wouldn't you? Stuck at home with nothing else to do.
I'm not sure about that.
It'll be written kind of like this, I think. I'm trying to write this from memory here. I'm pretty sure that's the way it's written in the math textbook. That's the official math way to say, add the exponents together. As rules go, this one's not too complicated. And the beautiful thing is it works for any kind of exponent problem you have, as long as the bases are the same. In the problem we just did, the bases were both 4, and then the product rule that I wrote out there in blue, the way you'll see it in the textbook, both of the bases are A. The bases have to be the same for the product rule to work. If the bases aren't the same, it doesn't work out for you. So if I had like x to the 4th times x to the 6th, that one wouldn't be a big deal. That would be x to the x to the 10th. But if I gave you x to the 4th times y to the 6th, that is not equal to xy to the 10th or something, however you want to write that. This is wrong. The bases must be the same. Don't do it. Okay? Now, since the only criteria here is that the bases have to be the same, we can have more than one thing. You can have more than one, I think those are called, I don't think term is the right word. More than one, more than two. I don't know what each one of those things are called. I'll have to Google it later. I don't think it's term. Anyway, it doesn't matter. I have 3 things together. I just add the exponents to all 3. This will be y to the 3 plus 2 plus 7, which is y to 12. Also works if you have something goofy like negative bases. Now with the negative bases, the bases have to both be in parentheses. We talked just a few minutes ago about how -5 in parentheses and -5 not in parentheses aren't the same thing. But as long as they're each in their own set of parentheses, we're okay there. What do you think? What's your guess?
Parentheses, -5, exponent 15.
Very good. Exponent 15. You are so smart, Kelch. Good job. So let's look at one that's a little goofier. Let's do a little more complicated product rule here. Let's go ahead and take one that has both numbers and variables in it. So if I did not have the variables in here at all, this would just be 2 times -3, which is not a big deal. And if I didn't have the numbers in there at all, if I just had x squared times x to the 5th, that wouldn't be a big deal either. We just talked about how to do those. So when you solve a problem that has both numbers and variables in it, that's how you do it. First, you multiply the numbers together, then you multiply the variables together. Since it's multiplication, the order does not matter. Doing 2 times 3 is the same thing as doing 3 times 2, which means that doing 2 times x times 3 times x is the same thing as doing 2 times -3 times x squared times x to the 5th. In multiplication, the order does not matter. which is useful to us because now we can just do 2 times -3, which is -6, and x squared times x to the 5th, which is x to the 7th. Pretty easy, yeah?
Yeah.
Yes, no, maybe?
Sounds good.
I will take your silence as a Yahoo, I got it. So tell me what you think about that one.
Not great.
Yeah.
Not great, okay. Not great, I'll take it. It's not that bad. We've done worse things.
Very true.
Tell me what you think.
You would just add the
Can't hear you. I mean, like I can barely hear you.
X's and then for your Y's. Huh.
Yeah.
X to the what? The X goes to what power?
The 5th?
Yes. And Y goes to the,
Just the 3rd, I would guess.
very good, the 3rd. That's a good guess. Because the first Y, even though we didn't write it, has an exponent of 1.
Yeah.
Yeah, perfect. Works with negatives. Negatives mess you up. Don't let negatives come between you and your friends. So that negative is really a -4. I mean, sorry, -1. I'm doing -1 times 3, which is what?
-3.
Yeah, -3. And then I just move on down the line with the variables. So I've got a to the,
The negative, or the 8th?
8th power. And b to the,
8.
b to the what?
13. The 13th.
13th. There we go. Perfect. So that's the power rule. Let's move on to the product rule. So the product rule looks like this. Sorry, I just did product rule, didn't I? Power.
Yeah.
You were just going to let me go all the way down and be like, wait, there's another product rule? The power rule. And it's called the power rule because it's got 2 powers in it, or 2 exponents in the same problem. One base with 2 exponents. It looks worse than it is. Now, again, I'm going to start off by showing you the bonehead stupid way to do this. And you will be able to quickly see the pattern, I think. 7 squared to the 5th power is the same thing as 7 squared times 7 squared times 7 squared times 7 squared times 7 squared. 7 squared 5 times. Which is, well, now it looks a lot like the product rule. It's just a whole bunch of bases multiplied together. So I can just add the exponents. 2 plus 2 plus 2 plus 2 plus 2. My answer is 7 to the 10th power. Again, it's fine to solve it that way. If you want to write it out like that, don't let me stand in the way of your dreams. If what you really want to do in life is write out 7 squared 5 times, that's cool. But is there perhaps a shortcut to go from the problem to the answer without having to write out 7 squared all the time? What am I actually doing here?
You're just multiplying the exponents.
That's exactly right. I'm multiplying the exponents. So if I were to give you something like, I don't need to go through the whole process of writing y to the 8th times y to the 8th times y to the 8th. I just multiply the exponents. This would give me y to the 8 times 5 is 40. The official math way to write the power rule, because I know you're dying to know, you're so curious, is like this. So the big difference between the product rule and the power rule is that in the product rule, you are multiplying 2 different bases together, 2 of the same base, but the point is there are 2 bases. In the power rule, it's only 1 base. It's just got multiple exponents. What you think?
8 to the 20th power.
Very good. Okay, let's do one more of these. Let's do one with brackets in it just to see if we can really ruin your life. Oh my gosh, what is happening? Don't let the brackets mix you up. Brackets are exactly the same thing as parentheses. They function in exactly the same way.
So you just multiply the exponents together, what, right?
Uh-huh. So what would my answer be?
-5 to the 21 to the 21st power.
To the 21 is fine. We knew what you meant. Oh my gosh. You hear my child in there screaming? She is not having a good night. I think I'm just going to hide out in here and pretend like I'm doing class for 4 hours. Okay. Now this, I'm going to write down this rule, power of a product rule. I don't know that you're going to need to write down specifically what this is. It's pretty easy. The power of a product rule looks like this. Oh, mommy's shouting at the kid. If you listen really carefully, you can hear her soul leave her body. So this says that if you have 2 different bases in parentheses that are raised to an exponent, everything in the parentheses gets that exponent. It's a pretty, I think you would have figured it out if I had never told you. You would have figured out this rule. I think it's pretty easy to get on your own. If you have st to the 4th power, this is, again, I'm going to do the dumb way to do it. This is st times st times st times st. So when I count my s's, I have s times s times s times s, so that's s to the 4th. And then I have t times t times t times t, so that's t to the fourth. And it does not take someone who knows rocket surgery to figure out what the shortcut is. Each thing in the parentheses gets the exponent. So it's a good rule to know. I guess it's a little silly. What do you think here?
Two to the third power and 8 to the third power.
Good. So 2 to the third, a to the third, and if you really wanted to, 2 to the third is a small number. 2 to the third is just 8. We can do 8, a to the third. That's fully simplified. They're both correct, but generally if the exponent's small, it doesn't hurt anything to just go ahead and multiply it out. So 2 to the third, right? That is 8. Pretty good idea. Nobody's gonna kick you out of the math party if you don't do that. So what if the thing that's in the parentheses already has an exponent? Then what do you do? Well, the first part's pretty easy. It's just 1/3 to the second power. I don't need the parentheses here, but I'm gonna go ahead and put it in there just so it's easier to read. 1/3 to the second power. Then I have m to the second power. And then I have n cubed squared. So that's going to look like n cubed squared. So 1/3 squared is 1/9. You square the top and the bottom. Then we just got m squared. And finally, we have n cubed squared, which is going to give me
N to the sixth.
Good. Let's do one with negatives and then we'll move on, because these can be a little tricky as well. Just because a negative base, it makes a difference whether it's in parentheses or not. So because the -5 is in parentheses in the problem, it has to also be in parentheses when I square it. So I need to do -5 in parentheses squared. Then I do x squared squared. The next thing in the problem is y cubed. So I do y cubed squared. And then the last thing is z, so I do z squared. Every single thing in the parentheses has to get squared. So -5 squared means -5 times -5, which is 25. X squared squared is x to the fourth, because I'm multiplying them, not because I'm adding them. Y cubed squared is y to the sixth power. And then on the end, I just have z squared. There's my answer. Okay, closely related to this, very closely related to this rule is the power of a quotient rule. Quotient, of course, means division. So this is how these rules apply to division. For example, if I had y over 7 raised to the 4th power, it's pretty easy to guess where this is going. It does the same thing that the power of a product rule did. Everything in parentheses gets the exponent. So this will be y to the 4th over 7 to the 4th. And we're going to leave it as 7 to the 4th because 7 to the 4th is actually a pretty large number. Pretty big number, like over 2,000. So we'll just leave it like that. If you had something like that, it's pretty basic what we're doing here. We're just putting the 7 exponent on both of these. M to the 7th over n to the 7th. The only time these get tricky is if the thing that's inside the parentheses is not as simple as just an m and an n. For example, something like that. So everything in the parentheses is going to get that exponent. So this is going to be x cubed to the 4th power on top. On the bottom, I will have 3 to the 4th power, and I will have y to the 5th to the 4th power. So that'll give me x to the 12th on top. 3 to the 4th power is 81. Oops. Not bad. 3 to the 4th power is 81. And then y to the 20th. Ugh. Oh, nope, there's just no good highlighter color for that. Okay, that one's not too bad, right? Okay. Now let's move on to one that is a big deal. The quotient rule for exponents. And the quotient rule for exponents says this. If you are dividing two things that have the same base, the way you put them together is by subtracting the exponents. And that one's a big deal. So for example, if I had something like this, the way that I would put them together is that I would have, I'm showing you the dumb way again. If I wrote it out the long way, that's what I would end up with. Remember, anything divided by itself is 1. So these x's will equal 1, and I can cancel those out. These x's will equal 1, and I can cancel those out. Those x's will equal 1, and I can cancel those out. And what I'm left with on the top is just 2 x's. So my answer would be x squared. I subtract the exponents. That's the shortcut, rather than writing them all out and canceling them. But it's important to know that the way we get them is writing them out and canceling them. That's going to come up in just a second. So what's the answer to this one? Four to the fourth. That one's not terribly obnoxious to multiply out. 16 times 16, 256. That's not bad. It, of course, works with negative bases. So this would be -3 to the,
To the third power.
good. That one's also not terribly obnoxious. -3 times -3 times -3 is -27. So that one's not too bad to go ahead and multiply out. Just like the product rule, this only works if the bases are the same. So for example, something like that, I can't put those together at all. There's nothing I can do there. The answer is just that. No simplification. And the worse these get is whenever you have multiple bases in the same problem, you just take them one piece at a time. So first I look for the constants. I have a 2 in the top and I don't have any constants in the bottom, so I'm just going to leave the 2 in the top. Next comes the x's. I have x to the 5th and x. That would give me
X to the 4th.
And then I'll check the y's. Y squared over y is going to give me
Just y.
okay. Let me ask you a trick question. What's that?
Zero?
It's a really
Three.
common and a really good guess. Question is, based on what you just learned about the quotient property, what would it take for you to have an exponent of 0? How would you get an exponent of 0? That means that whatever was in the top and whatever was in the bottom would have to have the same exponent, so that when I did 4 minus 4, I got 0, right? But what is anything divided by itself?
1.
1. So the answer to this problem is 1. In fact, anything raised to the power of 0 is 1.
Nice.
So if I give you something awful and it's to the power of 0, the answer is
1.
1. Now be careful. What about something like this?
Be -1.
It's -1. The 5 gets raised to the 0 power, but then we've got a negative in front, so that is -1. What about this?
It'd be 4.
Yes, the answer there is 4. X to the 0 power is 1, and then we have 4 times 1, which is 4. What about this? So this is why I put an asterisk next to anything. Here's my asterisk. Not anything, anything except for 0. Because for me to get 0 to the power of 0, what I would have to have is like 0 to the 3rd over 0 to the 3rd. So that I end up with 0 to the 3 minus 3 power, which is 0, right? That's how you get 0 to the power of 0, something like that. But look what I have in the denominator. Dear Will Robinson. I'm dividing by a 0. 0 in the denominator means divided by 0. And as you know, dividing by 0 brings about the apocalypse. And so the answer to 0 to the 0 power is actually undefined because we are dividing by 0.
Nice.
So I'm a liar.
Hmm.
I said anything 2 minutes ago. I meant almost anything. But honestly, you people should be used to this by now. I'm a big old liar. Just kidding. I'm perfectly proportioned liar. Let's talk about negative exponents. This is really tricky. Negative exponents in general are a no-no. I have something to a negative exponent. That's a problem for me. I don't like negative exponents. So one of the things that I would do to fix a negative exponent is I would turn it into a fraction and put the negative exponent in the denominator, just like that. That's one of the ways that I would get rid of negative exponents. Make it into a fraction, put the negative exponent in the denominator, and as if by magic, it becomes a positive exponent. What do you do if it's negative and it's already in the denominator? Well, that's really nice. You just move it up into the numerator and make it positive. So this one's going to take a little bit of practice. This is not quite as intuitive as the other rules. So if I had something like 3 to the negative second power, that would be the same thing as 1 over 3 to the positive second power. And 3 squared is 9, so 1. Okay, what if you've only got one thing that has a negative exponent? 2x to the negative third power. If that happens, only the thing with the negative exponent moves into the denominator. The 2 doesn't have a negative exponent. It's just 2. So I leave the 2 alone, and the x to the negative third moves into the denominator where it becomes x to the positive third. You can get really creative with these because I know you want to.
Not necessarily.
First, I know you do. 2 to the negative first and 4 to the negative first. So 2 to the negative first is 1 over 2. And 4 to the negative first is 1 over 4. Notice that I dropped the 1s there, the negative 1 exponents, because 2 to the first power is just 2. And now I have 1/2 plus 1/4, which is 3/4. A word of caution here, if your base is negative and your exponent's negative, you move it into the denominator to make the exponent positive, but only the exponent changes. So this will be 1 over -2 to the positive 4th. The bases don't change when you shift it, only the exponent, not the base. Okay, what about the other way? Any guesses what that would be?
X to the
It would be
negative X. No?
The base doesn't change, only the exponent does. So I put it up in the numerator, x to the positive third power. The base doesn't ever change, only the exponent. Here, let's see if we can really ruin your life.
No.
Now I got 2 negative exponents. Holy crap.
Oh,
You just flip them.
What do we do?
move to the next question.
Yeah, skip this one. Copy up the person next to you. No, if it's got a negative exponent, you move it. So this q to the negative 9th has a negative exponent. It's going to move up into the numerator, q to the positive 9th. This p to the negative 4th also has a negative exponent, so it's got to move. But since it's in the numerator, it moves down into the denominator, and there's my answer.
Kind of like almost the reciprocal.
It's exactly the reciprocal.
Okay.
Good word. Every one of these is the reciprocal. Even this one over here with the x to the 3rd, that was also the reciprocal. I just didn't write the 1 on the bottom, but that was the reciprocal too.
Okay.
What a smart cookie. Okay. Now, that last one with the p and the q, they had different bases. What if they're the same base? So, let me try again. So one of the ways you can do this is by using the quotient property we learned, which says whenever you're doing a quotient, you just subtract the exponents. You have a 1 exponent on the top and a -2 on the bottom, so you could just do 1 minus -2. That's totally fine, but to me, I think it's a little confusing to do minus a negative. That kind of math mixes me up. So what I might do instead is I might leave the plain old y alone because it has a positive exponent. Take y to the -2 and move it to the top so that it becomes positive. And then use the product.
Nice.
Y to the third. Now in that problem, it's totally fine to do this. To say, oh, this is y to the, and the top one was 1, and then you subtract the exponent on the bottom, which was -2. 1 minus -2 is 3. That will get you the answer, but I just think that's unnecessarily confusing to try to do it that way because you have such a potential to make a mistake with like minus a negative. That's pretty gross. So if we're going to do it that way, let's talk about what you would do if the negative is on the numerator instead of the denominator. Again, I'm not going to mess with the x to the 7th. It's fine. X to the 5th, though, -5th, has got to come down, become x to the positive 5th. When I do that, the numerator is now empty. So what do I put in the numerator?
1.
1. Good. So I have 1 over x to the
35th power? No?
You're thinking if I've got a base with 2 exponents. This is 2 bases. So I don't multiply by exponents.
Right?
Hmm?
So the second power?
That's if I have 1 on top and 1 on bottom. They're both on the
I don't-
bottom now.
Would you add them?
Yelchits, you sound like Hal 9000. I'm going to assume Kelch said 12th. Good job, Kelch. You nailed it. Now saying Daisy, give me your answer due.
So you just add them.
Okay, how about this? Let's put it all together. So on the top, let's deal with the 4 exponent first, because that's like the outermost thing, the set of parentheses we got to deal with first. So this will be 2 to the 4th and x to the 3rd to the 4th. And then on the end of that, we just have plain old x, poor guy. On the bottom, x to the 7th. So we dealt with our first exponent, but we still have a second exponent to deal with that x to the 3rd to the 4th. So let's take care of that. Also, just to make things easy for ourselves, we'll go ahead and multiply out the 2 to the 4th, which is 16. X cubed to the 4th is a power rule. So it's 3 times 4, which is 12. And then we've got that little x on the end, poor guy. X to the 7th on the bottom. Then we've got the product rule. 16 x to the 13th over x to the 7th. 12 plus 1 is 13. And finally, the quotient rule, 13 over 7. So 16 to the, and then I do 13 minus 7. Which is x to the 6th. And that's the answer.
Nice.
Okay, here's your last problem. And I am going to post this video online, and I'm going to post these notes on Blackboard. So if you missed anything, you can go back and take a look. Or if you didn't miss anything, but you're just like, that math was so, so good. I want to do it again. You know, like how you go see really good movies twice? You do that.
Yes, I do it.
Learning math is exactly like going to a really good movie, is what I'm saying. So,
Not sure that's true.
yes, it is. So the cubed on the outside has to go to every single thing in the parentheses, which is the whole problem. The whole problem is in parentheses except for that cube. So every single thing gets cubed. So the -2 gets cubed, the x cubed gets cubed, and the y gets cubed up on the top. And on the bottom, the x gets cubed, and the y to the -1st power gets cubed. So I can go ahead and do -2 to the 3rd power. -2 times -2 times -2 is -8. And then x cubed, that's a power rule. So x to the 9th, y cubed. On the bottom, we have x cubed. And then we have y to the -1st cubed, which is y to the -3rd. It is so, so tempting to look at y to the third and y to the negative third and say, boom, they're gone. They're both third, I'm out. But that's not okay because they aren't the same. They only cancel if they're the same. One's positive, one's negative. They might as well be completely different numbers. I mean, they are completely different numbers. So we can start with the -8. There are no other constants in the problem for us to divide that with, so that's it. Then we can look at the 9th and the 3rd on the x's there. X to the 9th over x to the 3rd is x to the littering and
No, not 6.
huh? X to the, I didn't hear what you said.
Oh, I said 6.
Yes, x to the 6th. And then this y to the -3rd has to go up top to become positive, y to the +3rd. So I have y cubed times y cubed, which is y to the
9.
what?
9. No? 3 times 3?
Yes, that is 3 times 3, but that's if we have one base with 2 exponents. This is 2 different bases. You did the same thing on the last problem.
I know, I'm going to have to rewatch this darn video.
So here's how you keep it straight. If you've got something that's like this, that means multiply. When you have one base with 2 exponents, you multiply. If you have 2 different bases, that means add. So if you have something with a double exponent, you multiply them. If there's no double exponent, you just add them together. So it's like back on this problem that we just did. You look right here, we had x to the 3rd, which turned into x to the 9th. We multiplied them. But here we had y to the 3rd and y to the 3rd. We added those because they each had a y in them.
Okay.
If they each have their own base, you add the exponents. And if it's a single base that has double exponents, that's when you multiply.
Okay. That makes
Good. Does anybody have any questions?
That was my question.
Your question was what?
How do you know when to add and to multiply
Gotcha.
the exponents?
I gotcha. Carmen, do you have any questions? You've been awfully quiet.
I'm good.
All right, I'm going to go ahead and upload this video right now, and I'll put the notes on Blackboard so that you will be able to go back and look at this a little later.